In this lecture, we're going to talk about environment variable, especially AWS account and region. So how does AWS determine which AWS account and region that it needs to deploy those services to? So there are two ways in which you can do this. So the first one is you explicitly define the account and the region that it needs to be deployed in. The second option is based on the CLI configured, it will automatically deploy to the region and account which you have defined for the CLI. So if you remember, when we were configuring the CLI, we had created a role and then we had defined the region for that particular role. So let me just show you. So you can see this is the demo CDK Lambda that we created in the last lecture, and you can see it is deployed to North Virginia region, which is US East 1. So how did it determine which region to deploy? Because we hadn't provided any of these configuration information here. So if I go to bin, you can see we are not provided any account or region information. And this was based on the configuration of our CLI. So if I go here and say AWS configure, so it will ask for my AWS key ID. It will show my secret access key. And then it will say default region name. Here you can see it's US East. So that's why it's taking the default region and deploying all our services to US East. So that's the second scenario we discussed. Now say I want to deploy it to Ohio region. So US East 2. So what we can do in that case is, so you can go here and you can see if you go to the infra bin infra.ts file, and here it is given some boilerplate information that's provided here. And this is the same thing it says. So uncomment the next line to specialize this stack for AWS account, and the region are employed in the CLI configuration. So if you want to use the CLI configuration, then you can uncomment this. And if you want to provide the account number and region, then you uncomment this. So this is what we are going to do. So I'm going to get rid of this. I'm going to uncomment this. I'm going to get rid of this. Okay, so now I'll provide my AWS account number. So let me do that. If I go to console, and here you can see my account number, so I can just copy this and make a change here, and then I can change the region to US East 2, which is Ohio. Okay, that's pretty much it. Now if I go and deploy this, it will deploy this Lambda function in the US East 2, which is the Ohio region. Okay, let me do CDK deploy. Just remember one thing, the change that we need to make is within the bin infra.ts file and not the usual where we write lib infra-stack.ts, not here. So it has to be within the bin folder. Now let me do a CDK deploy. And let's see if this gets deployed in the US East 2. So I'll pause the video for a little bit. Okay, I waited a little bit and it's giving me error that there is no bootstrap that has happened because we did the bootstrap in the US East 1 and we don't have anything in the US East 2. So that's what we will have to do. So I'll do a clear and I'll say CDK bootstrap. And you can see if I go to this is North Virginia. So I will go to Ohio region and I will go to the CloudFormation. So we'll go to CloudFormation. And right now we don't have any Lambda function as well. You can see it's blank. Now it's bootstrapping, so it's creating that stack, still in progress. And if I just go to Lambda function, you'll see we don't have any Lambda function there, zero Lambda function. And let me open the CloudFormation. Okay, it's still in progress. So I'll pause the video for a little bit. Okay, now it's bootstrap. So let's run clear and let's say CDK deploy. And let's wait for a little bit. So it's asking me if I want to deploy. I'll say yes. Let's look at the CloudFormation. So bootstrap is complete, but we don't have any deployment stack as yet. Okay, so I waited for a little bit, about more than a minute, and now it's created the infra stack. Now let me just go here and do a refresh. So infra stack is complete. Let's go to the resources, flat view, and this is our Lambda function. And you can see it has created the demo CDK Lambda but this time if you see the region, it is Ohio region. So that's how you can define the AWS account number and the region, because you might have multiple accounts where you want to deploy your services. So you can define the account and region and then deploy it appropriately. In this lecture, we're going to focus on CloudWatch, and we're going to create a CloudWatch alarm for Lambda function. So we know that CloudWatch is used for monitoring and alerting based on certain metrics. So we'll use the same Lambda function that we created in the previous lecture and then define one of the metrics. And once that matrix is breached, it is going to generate a CloudWatch alarm. So now let's see what are the metrics available for Lambda function and which one we can use. So you can see I am on a page defined by AWS working with Lambda function metrics. There are multiple metrics that you can use for invocation. So you have the invocation, so number of times the function code is invoked, including successful invocation that result in a function. So that you can create one metrics on that. You can create an errors. So if there is any function error on invocation, then you can create a CloudWatch alarm. And this is a very common metrics that you use. Anytime you invoke the Lambda function for whatever reason, if it doesn't run, then it should generate a CloudWatch alarm. So there are other metrics as well: performance metrics, duration, iteration, age, offset, lag, concurrency, etc. So what we'll focus on is this error. If for whatever reason our Lambda function is invoked and it does not run correctly, it generates a CloudWatch alarm. For that, if I go to this construct, we have this construct. I just search for AWS CDK CloudWatch, and this is the page it takes me to. So we'll generate a CloudWatch alarm here, and this is the module we have to import, and these are all the attributes. Okay, so now if I go to step-by-step guide, since we are going to use the same Lambda stack, so we don't have to go through these 3 steps again. So we'll start from here. So we'll import the module, then we'll define the scope, logical ID, and props. So let me go here, and this is our old code that we had used for creating the Lambda stack. So I will say CloudWatch alarm cloud. Before that, I have to import the module. I'm sorry about that. So I will say, maybe I'll just copy this thing. If you can see, this is the step we had to do first. So I will say import star as CloudWatch, and I'll just make it lowercase from, and as we saw, it's CloudWatch. Should give an auto option. CloudWatch. Okay, great. Now I think it has imported the CloudWatch. Now we can go ahead and give this CloudWatch demo, and we'll say is equal to new. Then we'll say what we had imported from here, which is CloudWatch. So CloudWatch, and the construct that we're importing is alarm. So I'll say alarm, and it should give me an option. Then I will say the scope, which is this. Logical ID is a string, so I'll say CloudWatch logical ID, or whatever name you want to give, and then we'll give the attributes or properties. Okay, before we start adding the props for this CloudWatch alarm, let's go to the console and understand a little bit about what the props for CloudWatch. So let me just go and search CloudWatch. Okay, so I'll just show you how to create an alarm from the console, and then we'll look at the properties and map them to what we would put in the CDK code. I'll just click on this create alarm, select matrix, and you can see I'm in the Ohio region here. So I will search either for the specific service if it's not available here, but I can see the Lambda function here. So I'll just click on Lambda by function name. Okay, so we already have the demo CDK Lambda that we created earlier in the lecture. So you can see all the metrics that are available for this demo CDK Lambda. So we have the errors, concurrent executions, invocation, etc. So we're going to focus on the errors part. So every time our Lambda function is invoked and there's an error, CloudWatch alarm would be generated. So let me just click on this and select matrix. Now you can see we have to provide all these attributes. So namespace, so the convention is AWS, and whichever service you are using. So we're using AWS Lambda. Now the metric name we discussed is errors. Then we have the function name. So next one is statistics. So it can be average, sum, maximum, minimum. So what it means is, say you are evaluating 3 times over a period of 5 minutes. So 5 minutes, 5 minutes, 5 minutes. And in the first 5 minutes, you get 0 errors. Second 5 minutes, you get 3 errors. In the third 5 minute period, you get 2 errors. So you can either do an sum, average, max, minimum. So you can just choose that. So we'll just choose average for now. And then there is period. So period is like 5 minutes, 10 seconds, 30 seconds. How often do you want it to evaluate the condition? So if you evaluate over 5 minutes, it's free. But if you do less than 5 minutes, then you're going to be charged for it. So then we have the threshold type. It can be static. You compare to a static value, or you can compare over a band. So that is for anomaly detection. So we're going to use just static value. Static value would be like just one error over a period of 5 minutes, and a CloudWatch alarm should be generated. So the threshold is after how many errors should the CloudWatch alarm be generated. So then when error is greater than equal to lower or lower than the threshold. Say if you want that over a period of 5 minutes, even if there is one error, then alarm should be generated. So you set the threshold as 1 and then say greater than the threshold or greater than to equal to. So I'll just put greater than equal to. Then you put the threshold value, which would be 1. And let's look at this. So data points to alarm. So what this means is that, say you are evaluating after every 5 minutes, and you want to, when you put the data points, say 2 by 2 here, what it means is that you evaluate over a period of 5 minutes and then second 5 minutes. And if you put say 1 by 2, so over those 2 periods, if one matches the condition, then the alarm is going to be generated, but it will wait 10 minutes. If you put 2 out of 2, then it has to fail in both the time periods, the first 5 minutes and the next 5 minutes, for alarm to be generated. Now with this knowledge, let's take a look at the props for, okay, now let's take a look at the props that we have here. So these 3 are the mandatory ones. So threshold, if I look at the threshold, this is the threshold. How many errors do we want before the alarm is generated? So whether 2 errors or a period of 5 minutes, 3 errors, so threshold we have to set. Then the next one is the metrics. So metrics we already discussed. The metrics we are going to use is errors. And the third one that we have here is the evaluation period, the number of periods over which data is compared to the specific threshold. And this one is the data points to the alarm. Now with this knowledge, let's go ahead and create an alarm. So I will go to the code editor. So I will say evaluation period, and it just shows me here. And I will say 1, it's a number. And then I will say threshold. Again, even if there is one error, it should generate an alarm. The third one we have is the metric. So now let's take a look at how we need to define this. Okay, if you can see at this metric error, so what we'll have to do is, this is a metric related to the lambda function. So if I go to the lambda documentation, you can see here, and then go to this function construct. If I search errors, you can see the metric error is here. How many invocation of this lambda fail? So this is what we have to use, and you can see there's an example as well. So here's an example as well, metric alias metric errors. Okay, so maybe I'll just copy this and paste it here. And this is going to be our lambda function name. So that will be demo lambda. Demo lambda. Yeah, I think that's pretty much it. That should generate the alarm for us. So let's go ahead and try it out. So I'll say CDK deploy. So I'll pause the video for a little bit. Okay, I just waited about 30 seconds and it has generated the stack. So let me go to the CloudFormation and let's see what's going on. Okay, I'm on the CloudFormation. So this is the stack we have created. Let me go to resources and client view. So this is the CloudWatch alarm that's been generated, and this is the lambda function that we had created in the earlier lecture. So let me just go to this CloudWatch alarm. And you can see this CloudWatch alarm has been generated. This is the randomly generated name because we did not provide the CloudWatch alarm name. And you can see some details related to it. So the namespace is AWS Lambda, metrics name is error, and the function name is demo CDK Lambda. And the period over which it's going to evaluate is every 5 minutes. And data points we had alarm we had provided, which was the evaluation period, and threshold is 1. So you can see in the alarm. So this is 1. If there is even one error, then alarm would be generated. So right now it doesn't have any data, so it can't generate the alarm. So now let's try and run our Lambda function. So let me just create a test event. Test. Okay. Let's save. Okay, I'll go back to the Lambda function source code. Okay, so I think it ran okay. So let me run it once more. Okay, so there should be no CloudWatch alarm being generated. You can see it still has insufficient data. Okay, now let me modify this Lambda function and generate some syntax error so that this Lambda function fails on invocation and it can generate an alarm. So let's just do deploy and test. It generated a syntax error in the module Lambda function. Okay, now our CloudWatch alarm should be generated, but you'll see it will take some time because it evaluates over every 5 minutes. So we'll have to wait for 5 minutes before it can generate an alarm. Right, you can see right now it's showing as okay because it has to evaluate over every 5 minutes. So we'll have to wait for a little bit. I'll pause the video for a little bit and then we'll come back. So you can see it is giving me one error, but since it's not crossed the threshold, so we'll have to run it a couple of more times so that we get more errors and it can cross the threshold. Okay, I waited a few minutes and now you can see this CloudWatch alarm has been generated and is in the alarm state. You can see here in the alarm state, this is the one which we had created. You can see some of the errors that it's showing here. So you can see it's gone beyond the threshold. So it's gone to 5 because we ran it multiple times and it failed. So this is how you can generate a CloudWatch alarm and then send an email notification through SNS, etc. to monitor your Lambda function. Hope this was useful. Thank you. One of the common feedback that I have received for the course is to elaborate a little more on what is the use of CDK destroy command and how it impacts various AWS services, especially the S3 bucket, and how we can override the default behavior for these services in the CDK. So this is what I'm going to discuss in this video. Now let's go ahead and do some hands-on and see how this is implemented in practice. So this is a code I have taken from one of the previous lectures where we created the Lambda function, the CloudWatch alarm, and I just deployed it. So you can see here in the CloudFormation stack, so it's created the CloudWatch alarm Lambda function, and by default it also creates an IAM role so that Lambda function can write to the CloudWatch alarm. Now if I click on these services, you can see this IAM role has been created. This demo Lambda is there, and we have the CloudWatch alarm. Now let's go ahead and run the CDK destroy command and let's see what happens with these services. So let's say CDK destroy, and I'll just wait for a little bit. Now you can see this stack has been destroyed. So if I go here and just refresh this IAM role or the CloudWatch alarm, you will see that this alarm was not to be found. And similarly, if I do a refresh for the IAM role, it says that one of the entities that you specified for this operation does not exist. So it's deleted this IAM role, and this Lambda function is deleted as well. You'll see that it doesn't show anything. It will show some other AWS Lambda functions. Okay, nothing to display. And if I go to CloudFormation and just do a refresh here, you'll see the CloudFormation stack corresponding to this does not exist as well. So what we learned is once we ran the CDK destroy command, it deleted the CloudFormation stack and all the services associated with it. So IAM role, Lambda function, and CloudWatch alarm. Now let's run it for the S3 bucket and see what happens. Okay, now I have taken the code for S3 bucket that we used in one of the previous lectures. I just changed the bucket name and I deployed it. So let's go to the CloudFormation stack and we can see the resource here. View, and you can see the S3 bucket that we have created with the date 23rd July 2023. Now I will go here and we'll go here and let's do CDK destroy. I'll just pause the video for a little bit. Okay, now you can see it has been destroyed. The infra stack has been destroyed. Now let me go to the CloudFormation stack and you can see here the delete has been complete for this infra stack that we just created. But when I go to the resources and if I just go here, you can see it's showing as delete complete for metadata, but for the S3 bucket, it's showing as delete skip. And if I go to this S3 bucket, you will see that this S3 bucket still exists. So you can see the difference in the behavior when we ran the CDK destroy command for Lambda, IAM role and CloudWatch alarm, where the stack and the resources were deleted. But in this case, the stack has been deleted, but the S3 bucket has been retained. Now let's try and understand why there's a difference in the behavior when we run the CDK command for various AWS resources. If you've worked on AWS CloudFormation, there is something known as deletion policy for resources. In AWS CDK, it is called as removal policy. Now, what's the impact of this CDK destroy command on specifically the AWS resources? If you have not defined the removal policy for that particular resource, there are three things that can happen. One, the resource can be destroyed. So this is the default removal policy for most AWS services if you do not specify the removal policy. And that's where we saw for IAM role, Lambda function, and CloudWatch alarm, these services were destroyed. The second option is the retain. So again, when you don't define the removal policy, there could be some services which will be retained. And that's what we saw in case of S3. And that's where we saw when we ran the CDK destroy command for the stack containing S3 buckets, the CloudFormation stack was deleted, but the S3 bucket was retained. And the third policy is snapshot. So this is prevalent in case of any kind of databases, especially RDS, where the resource is deleted, but the snapshot is taken. And if you look here, this is the policy from the CloudFormation. So you can see it supports snapshots for EC2 volumes, Elastic Cache, Neptune, RDS, and Redshift. So mainly for databases, the default removal policy is taking a snapshot. Now, why do we have retain and snapshot as default policies when we run the CDK destroy command? The reason is that AWS wants to make sure that you don't lose any data. So that's why for storage services and RDS, it tries to protect your data unless you override the default policy and mention specifically to destroy the service. And that's what we're going to see for one of the services. We'll take an S3 and see how we can override the default policy. Now that we have discussed what is the default policy for S3 bucket, let's see how we can override the default removal policy. So I'll just go to this link and I will copy this link. Okay, now I am on the S3 bucket construct and you can see here bucket deletion. When the bucket is removed from stack, the S3 bucket will be removed according to the removal policy. And if you don't provide any removal policy, the default one will simply orphan the bucket and leave it in your AWS account. Now what happens if we want to override this condition? So what I will do is I will go to this bucket construct and let me just go to the properties. So here you can see the removal policy to apply when the bucket is removed from the stack. So you can use this removal policy to change the default behavior. And you can see that there are three options: destroy, retain, and snapshot. And you can see for the snapshot, this is only available for stateful resources like databases, EC2 volume, etc. The ones which we had seen earlier. Now, if I can go back to the link which I had shown you earlier and look at the bucket deletion. So you can see here, so if you want to override the default removal policy, then you have to add a property called as removal policy. So I will just go here and then if I just go here. So we'll just add an attribute. So we'll say removal policy. And if I just go back to documentation, so you can see here cdk.removal policy.destroy. So I will say cdk.removal. You can see removal policy here. And dot will say either destroy, retain, and snapshot. So retain is the default, snapshot is mainly for databases or EBS volumes, and so we'll say destroy. And then I will just do a save. And now let me just do a clear. Now I will do a CDK deploy. Now you can see this infra stack has been deployed. So if I go to the CloudFormation and you can see the infra stack here, I'll just do a refresh. And if you go to the resources and flat view, and you can see, so here we have the demo 3 bucket 25th July 2023. Now if I go back and let me do a clear. Now if I do CDK destroy, it should destroy the CloudFormation stack as well as the S3 bucket, because we have explicitly defined the removal policy as destroy instead of the default which was retail. So now let's take a look. Yes. Okay, now it's showing that infrastructure has been destroyed. Now if I go to CloudFormation, so you can see here, if I go to stack info, you can see delete complete. Now if I go to resources and go to flat view, and if I click on this S3 bucket, you can see it says the bucket demo 3 bucket 25th July 23 was not found. So still there is one more thing we need to know. So what we did was we said we're going to remove the S3 bucket once we run the CDK destroy command. And for that we use this particular property. But this is only applicable and will work when the S3 bucket is empty. If you have objects in the S3 bucket, then it will not destroy the particular S3 bucket even if you use this removal policy as destroy. So what you additionally need to do is you need to include auto delete objects is equal to true. So you have to, it's a boolean, so you have to add it as true and then it should work. You can see in the documentation as well. To override this and force all the objects to get deleted during bucket deletion, enable auto delete option is equal to true. Okay, so let's do that now. I will just add one more attribute. So I'll say auto delete objects and here it shows me. So I'll say true, it's a boolean, and then I'll go save, and then I'll go CDK deploy. So once you enable this auto delete object as true, it would force all the objects and S3 bucket to be deleted. So this is how the removal policy works for various resources. Just to recap, for AWS storage services like S3, the default policy is retain. For databases, the default property is snapshot. For most other AWS services, the default policy is destroy or delete. But you have the option to override most of these settings through the removal policy attribute. So hope this is useful. Thank you. In this lecture, we're going to create an end-to-end serverless use case using API Gateway, AWS Lambda, and S3 using the AWS CDK V2. So first thing we're going to do is we're going to create an S3 bucket using the CDK V2. Then we're going to load a JSON file on this S3 bucket, which would have a single record. And let me just show you. So this is the JSON file we're going to load, which will have name and account balance. Next, we're going to create an IAM role, which will attach to this Lambda function, which will allow the Lambda function to access the S3 bucket. So once we have created the IAM role, we're going to create the Lambda function, and I have written some Python code, which is going to read this data in the JSON object that we have on the S3 bucket. And the last thing we're going to do is we're going to create an API gateway, which will invoke this Lambda function. So end-to-end flow, how this will work is we'll have an end user who will have the access to this REST endpoint. And once he invokes this REST endpoint, it is going to trigger a Lambda function, which will execute the Python code within this Lambda function. And then it will read all the data that we have in the JSON bucket and present it back to the end user. So we'll go step by step. And for each service, I've created a separate video. As part of this serverless use case, we are going to create 4 AWS services. We're going to create an S3 as part of this serverless use case, we are going to create 4 AWS services. We're going to create an S3 bucket, an IAM role, an AWS Lambda, and an API gateway using the CDK V2. So we'll create a fictitious banking application where the customer can check his balance status on his account. So as part of this, we'll create a bucket name with balance status 0125. Then we're going to create an IAM role with these attributes, a Lambda function with the below defined attributes, and then finally an API gateway with the attributes. So we have two options. Either we can write the entire code and create one CloudFormation stack for all the services, or we can also create separate stacks for each service. So it will vary depending on various factors within an organization. But for now, we'll create a single stack which will create all these services. I've also created a summary of steps on how to create this entire use case. So we'll follow these steps to create all the services. So let me go to the Visual Studio and let's start coding. Okay, the first step is open the new folder in the Visual Studio code editor and open the terminal. So let's do that on my local. So I'll just say folder and let's call it as API gateway lambda S3. Okay, now I will open it in the Visual Studio Code editor. So let me just go to this. Okay, so I will open the folder we just created. Now I'll just open the terminal. Okay, as a step 2, we are going to create 2 directories. One is infra directory and then services. All the infrastructure code would go into the infra directory, and all the application code that you would write as part of the Lambda function would go into the services folder, and then we'll cd into the infra folder. So let's just do that. Okay, so we're going to create the infra folder first, mkdir infra, and let me do a clear. Then we'll do mkdir services, and I'll do a clear. And now I will do cd infra, and let's do an ls. Okay, it's blank for now, and you can see these 2 folders have been created on the left. Okay, in the step 3, we're going to initialize the CDK using CDK init app -- language TypeScript command, which would create a boilerplate code or folder structure for us. So let's do that. So let me do it clear. So I'll say CDK init app -- language, and we're going to use TypeScript. If you're going to use Java or any other language, then you have to give that name. So it's going to take a few minutes, maybe a minute or 2. So I'll just pause the video till then. Okay, now you can see the installation is complete and it's all done. And you can see within the infra folder, there have been multiple folders and files that have been created as part of this folder structure that gets created with this command. Now let's take a look at the next step. So next step that we have to do is we have to import the module for the AWS service that is being created. So I will just go to Google and search for AWS CDK v2. And in this case, we're creating S3, so we'll just search for S3. So in this case, we are creating an S3 bucket. So this is the module we have to import. So let me just go here. And first thing is I have to go to this lib folder and open this particular file. So you can already see there's some boilerplate code here where we have imported the core module AWS CDK lib, and it gets imported by default. Then we also have imported constructs. Okay, let me go here and then import the S3 module. So import as S3 from, so we'll say the core library, so AWS CDK lib you can see here, and then we just do a dash and then AWS -S3 or whichever service we are trying to import, and in this case it's S3, so it just shows me the autocomplete, so I just use that. Now the next thing we have to do is we have to define the scope, logical ID, and props. So the scope just tells what a service you're creating that tag is its parent, so it will always be this. And then you have the logical ID, which is more like a CloudFormation concept where you define the logical ID and then various services within the CloudFormation template can reference each other using the logical ID. And then finally you have the props or the properties or attributes of that particular service that you want to define. So I will go here and I'll say S3 bucket, and then the way you write this is, so you say, and you just give the name. So I will say man's status, and we can say S3, and then I will say new, and then whatever we have imported here, so you can see S3, so I will say S3 dot, and then it gives me all the different properties that are allowed for this particular module. So if I just go to the documentation, you can see here we have all the constructs that we can use. So we can use bucket because we're trying to create an S3 bucket, and it will show you all the properties that are allowed for this bucket. So you have access control and just describes here how to delete, and there's some other things that are there. And if there's a question mark, which means there's an optional. If there's no question mark, then it's mandatory. And for this, you can see it's pretty much everything is optional. Okay, I will just say here now the construct we have is bucket, so it will just highlight the bucket here. You see the construct here. Now then I'll just put a bracket, and then we have to put the scope. So we'll say this, comma, then logical ID. So we'll say S3 bucket logic ID. So it's just, you can just give anything you want, and then I'll just put a comma and then curly brackets, and then now we have to define the attributes. So we discussed that the only attribute that we need for this is the bucket name, and this is the bucket name I'm going to provide. So let me just copy this And you see here, once I start typing bucket, it will give an auto complete option. So here is the bucket name, and it also tells me certain properties related to this bucket name here on the right. So I'll just say bucket name, and then I'll just, it's a string, so bucket name status. Okay, so I think that's pretty much it. Let me just get rid of this boilerplate code. I'll just remove this as well. Okay, I'm going to slightly modify the bucket name. So let me just make it lowercase and remove this. That's pretty much it. This is the only attribute that we require. So now let me just go to this file infra.ts under bin, and let me just get rid of this boilerplate code first. So in this file, you can see we have the infra stack. Then it's very similar to what we had seen in the other file. So you have app, we have the scope, and then you have the logical ID. So let me just change this, and this will be the stack name. So when you go to CloudFormation, you have the stack name. So whatever you define here would be the stack name. So let me call it as banking status app 01. Okay, let me just do a save. Let me go here back to this file. Okay, now let's look at the next step. So the next step you have to do is you have to build the app. So you run the npm run build. It's an optional step, but if you do it now, it's going to give you all the syntax errors in your files if you have any. Otherwise, if you don't run, that's also okay. AWS CDK is going to run it by itself. But for now, let's just run it. So let's see. npm run build. So it's going to take about 30 seconds. So I'll just pause the video for now. Okay, I waited a little bit, and you can see it's not giving me any error. So it means this is okay. If there had been any errors, it would have shown the line number in the file where there are errors. Now let's take a look at the next step. So next step is bootstrap command. It's a one-time command. What this does is AWS CDK creates a bucket in S3 and uses that as a staging area where it launches IAM roles and creates some other permissions to launch the stack in CloudFormation. So let's run the CDK bootstrap command now. So I'll just do it clear and say CDK bootstrap. And it's just a one-time command. Once you run it, once that S3 bucket has been created, you don't need to do it every time. So it'll take about a minute. So I just pause the video for now. So you can see all these services are getting created as part of this bootstrap command. If I go to AWS CloudFormation, I should be able to see this stack. So you can see here CDK toolkit. This is the stack that's getting created as part of the bootstrap process. I just click on this. You can see here all the services are getting created. So you have the CDK toolkit. Let's just see the services that are getting created. Yeah, you can see you have the parameter store, IAM role, ECR repository, and other things that are getting created as part of this staging area. So you also have an S3 bucket. Click on this, it should show you the S3 bucket, which should be used as a staging area. Yeah, so this is the S3 bucket. Okay, now you can see this is complete. Now let's take a look at the next step. So the next step is we have to synthesize our CDK code into an AWS CloudFormation template, and you do it using CDK synth. So let's run that command. Let me do a clear. We should say CDK synth. So it's going to take about a minute. Great, now you can see it's been created. So you have an equivalent CloudFormation template. So let me just do it clear. And the last step that we need to do is we need to deploy this stack using CDK deploy. So let's do that. So I'll say CDK deploy. So I'll say CDK deploy, and shortly our S3 bucket with name balance status 0125 should be created. It's going to take a little bit of time. Okay, if I go to CloudFormation stack now, I can see the banking status app 01. And you can see the events. Okay, sources. You can see, I think it's created the S3 bucket. So if I go here, so this is our S3 bucket, and this is the name we had given. The next thing we have to do is we have to upload the JSON file on this S3 bucket. So that's what I'm going to do. So I'll just go to this upload and add files, and this is the account status JSON file that I have. Just click on this and do an upload. Okay, I think it's uploaded. You can see it here. It's a very simple JSON file with one record, and I'll just show you. can see here, it just shows the name and your account balance. So when the end user is going to invoke the API, these are the details he's going to be able to see when we complete the use case. Okay, now let's go ahead and create an IAM role as part of the same stack. So these are the attributes that we are going to add. So let me go to the stack, and here, let me say IAM role. Okay, so just going to push it a little bit up. So we're going to follow the same process. First, we're going to import the module for IAM. So let's say import star as IAM from. So I can just copy this thing and change here. And you can see it gives me an autocomplete option. And this is again coming from the documentation that we had discussed about earlier. So here's the IAM modules. If I just go to overview, and you can see this is a module we have to import. Okay, and since we are going to create a role, so I'll just go to construct role, and it will just give me all the attributes that you can use as part of this role. Okay. So now I have imported this module. So next thing I'm going to do is I'm going to write some code to add these attributes. So the first thing we're going to do is const IAM balance status role, and you can just give whatever name you want, is equal to new, and then we imported IAM from here. So we'll say IAM dot, and now you can see it's giving me some autocomplete options as I had shown you here. So we're going to use the construct role. So I'll say role, and it's giving me that option, and it also defines what are the properties of the right. I'll say the scope, which is this, and then logical ID. So logical ID, let's give it as IAM balance role, and then finally I have to give the properties or attributes. So the first attribute that we are going to use is role name, and this again, as I said, is coming from this documentation. So you have the role name here, then you have some other attributes that you can use. The only one which is mandatory is assumed by. So who is going to the principal that is going to assume this role? So that we have to provide. So let me go here, and first let me just say role name, and it gives me the option here, autocomplete, and it's a string. So I will say banking lambda role. Okay, just to make it unique. Then I just do a comma. So the next one we're going to use is a description and assumed by. So we're going to say description, and we can just say role for lambda to access S3 bucket. And the next one we're going to use is assumed by. Okay. It's a mandatory one, so we have to provide that. And now if I go to the documentation, you can see here the way you need to implement it is you have to define the service principal that is going to actually use this. And the service principal that is going to use this in our case is going to be the lambda function. So in the documentation, if I just click on this, and you can see from here that it's part of the interface. You also have the sample example here on how it needs to be written. So you have the new, and then you have the IAM, what you're importing, and then you have this particular interface, iPrincipal, and then you just write the name of the service that can assume this role. So let's say here, and we'll say new, then we'll say what we have imported from here. So we'll say IAM dot service. You can see it gives me the option service principal, and let me just go here and copy this. Okay, great. Now you can see the Lambda function can assume this role. So that's pretty much it for creating the role. But one thing we have not done is we have not provided it any policies. So the Lambda function can assume this role, but it doesn't have any policies. So we have to attach some policies to it. So here in the documentation, you can see you have multiple policies that you can attach. So you can attach an inline policy, you can attach a managed policy. So we're going to attach a managed policy wherein it can access the S3 bucket, because Lambda function has to access the S3 bucket to retrieve the data from the object that we have uploaded in the S3 bucket. So I'll just go to this managed policies. So you can see here you can use various methods to assign that policy to the role. So you have managed policy dot from managed policy name. So you can provide the managed policy name here. And then you have the policy ARN, you can use the policy ARN. Or if it is customer managed policy, then this is the one you have to use. But we are going to use AWS managed. So let me just go to this. So this is the method that you use to assign a policy to the particular role. So I'll just copy this and go here and just paste it here. Now you can see instead of the role, so this the role that we have here, the variable we have here, so we have to use this one. Okay. So the role you see here is basically this one. So I'm going to change that to the role that we have. So it's I am balance status rule. Okay. And the policy that we we need to have a policy name which will give it access to S3 bucket. For that, let's go to our IAM console and let's do duplicate. Let's search for policies. Let's say S3. Okay, so Amazon S3 full access. So I'll just copy this name and I'll just go here and paste it. Okay, I'll just do a save. Okay, I think we have pretty much everything we need to create this IAM role, and we had already created the S3 bucket. So now let's just do a clear and let's do a CDK diff, which tells us what's the difference between what we had earlier in the stack and what we have now. So you can see the changes. It's creating a new IAM role. Clear. And let's do CDK deploy. So it's going to take a minute or so. Okay, it's asking me if I want to implement the changes. Yes. Okay, I waited for about a minute or so. You can see it's taken more than a minute. And now this deployment is complete. So let's go to the CloudFormation template and see if the stack has been created. You can see now additionally, it's also created an IAM role that we had provided. So this is the IAM role, banking lambda role that we had provided here, banking lambda role. And the access it should have is to be able to access Amazon S3 full access. Okay, great. Next, we are going to create the AWS Lambda function. Okay, we have already created the S3 bucket and IAM role. Next, we'll create the AWS Lambda function. So I've already written some Python code which will allow us to read the data from this particular bucket that we just created. And this is the JSON file with one record that I had shown you earlier. So this is going to read the data, and then when we invoke the API, it's going to provide whatever is in this particular JSON file. So let's go ahead and create the Lambda function. Let me just do a clear here and push it down. Okay. Earlier we had discussed that infra folder is being used for all the infrastructure code and services folder is for the application code. Now we have to use the Lambda function which has our application code in Python. So let me go to this services folder where I'm going to put that code and create new file, and the file name would be this lambda underscore function.py. So name it as lambda underscore function.py. If you see, this is the normal convention that you use. So lambda underscore function.py would be the file name, and the method name would be lambda underscore handler. So if you do this through the console, this is a normal convention. So now I'm on this file, Let me just copy this Python code that I have. Okay, great. Okay, now we have this Python code. Let's go to our infra-stack.ts file under the lib where we had been writing the code earlier. So let me just say now the function. So the first thing we do is we import the module related to the lambda. So I'll say import as lambda from. Let me just copy this and we'll just change the service name. So it gives me an autocomplete. Okay, great. Now we'll write some code and the attributes that we are going to use as I had shown you here. So we'll use the handler, role, code, and runtime. Okay, let me go to the documentation. Here I'm on the Lambda documentation and this is the module which is imported. Now let's go to the construct, which is going to be the function. And you can see all the attributes in this function. So there's no question mark on code, handler, and runtime. So these are mandatory. So these three we have to provide. And then rest of them are all optional. So we're going to use some of them, but let's just see what we have here. So we're going to start with the role and then we'll add the handler, code, and runtime. I'll just say banking function. I would say new, and then whatever you imported. So that was lambda, and I'll say dot. The construct we have is function. So it will just give this function. I'll say scope, which is this, logical ID, lambda logical ID, and then I'm going to provide the attributes. First one is the role. This is basically the IAM role that we are going to provide it, which we had created here, and then handler, code, and runtime. So let's provide the handler first. So handler, and you can see it is going to be autocomplete. So the handler is the lambda handler that is going to actually use this. So I will say lambda underscore function dot lambda underscore handler. So this is this file lambda underscore function dash the method name we have. So the method name would be lambda handler. If you go here and you can see the method name that we have, lambda underscore handler. Okay. Okay, the next one we are going to provide is going to be the runtime, and our runtime is Python. So let's do that and let's see how we can include that. So if I go here to the documentation, so you can see here the runtime environment for lambda function that you're going to upload. You can see here once I'm on this runtime, the way you write it is the what you are importing dot runtime, and then you have the option of the language that you're going to use. So let's do that. So let's say lambda dot runtime, and it gives me that option, and then if you say dot, it will give me all the options it has. So I will go with Python 3.7, and the last thing we have to do is code. Okay, so let's go to the documentation on the code, and here it is. So there are multiple options on how you can provide the code path. So it can be either using from the bucket or from your local, which we are going to do from your local disk path. You can also ECR, you can do it from inline. So we're just going to follow the local disk path, and this is the method we are going to use. And it's also there's also an example there on how it needs to be provided. So you write the lambda dot code from the asset, and then you provide the path. So I'll say lambda dot code and then asset from asset, and then we have to just provide the path. So remember, the path for this code starts from this infra folder. So what you're going to do is, so you're going to provide dot dot, which takes you back to this folder, and then you're going to say dash services and dash. Okay, so the last one we are going to provide is the role that it can assume, and for that we are going to use the role that we have created, this I am balance status role. So I'll say I am, and it gives me this option here. Okay, so that's pretty much it that we need from the Lambda function perspective. So let's go ahead and run the CDK diffs to see what are the changes that are going to be made. So I will say CDK diff and we'll see the changes. Okay, it's giving me an error, and I think I know because the handler is a string, so that's the miss on my part. Okay, I think now we should be good. Let me do a clear and let me do CDK diff. Okay, it's showing me that it's going to create this Lambda function additionally. So let me do a clear and let me do CDK diff one. Okay, I just waited about a minute. You can see here total time, and it's completed the stack. So let's go to the cloud formation and see what's been created. Okay, let me do a refresh. And now we can see we have three resources. We already had the S3 bucket. We had the IAM role. Now we also have the Lambda function. So let me just click on this and just see. Okay, so you can see that this particular Lambda function has been created. And this is the file name lambda underscore function.py, and this is the code we had written. So we can just test it out and see if it works. So let me say test event and we'll save. Okay, now let's just try it out. So earlier we had seen that the S3 bucket that we had created, we had this particular JSON object in this, and if I click on this and click open, this is the response we should get. We should get the name and the account balance. So now if I run my Lambda function, so I do a test, this is the response I should get. Okay, great. This is the response I'm getting, what we have in the JSON file. Okay. And then I think we additionally have a status code.